Oh, okay.
Schaut gut aus.
Jetzt werden wir das nicht ändern.
Hi, Big Data Con audience. Welcome back to our second track here. Today, I've brought Karol with me. He's the founder of Codete. He's currently sitting in Berlin, what I have learned so far. Codete is a company with over 300 employees, deep into data science, but not only data science, also into security. Karol, I'm looking forward to your talk today about the problems that raising up with machine learning, especially security. Companies bringing more models into production, but maybe don't think in the first step about security. I'm looking forward to hear what attacks are possible there. I even wonder what data can be found there and what flaws are possible with that. And also to see the one or the other use case that you maybe have found online here, and looking forward to your talk, Karol. And the stage is yours. Please start sharing your presentation here.
Thank you, Jörg, for the introduction. Thank you, everyone, for joining my talk today. Yeah, my talk is, as you already know, about security in machine learning, how to build secure machine learning models. My background is AI, is computer science. I obtained a PhD in computer science a couple of years ago. Mostly I'm focused on in the medical field. I have you can find some of my research papers on skin cancer, for example. Now working on also on other type of illnesses on images, so computer vision in the medical field. Feel free to ask any question in the Q&A section during my presentation. I'll try to answer during the presentation or just after it if there is a if the answer would be a bit longer. You can also obviously find me on LinkedIn or just write me an email on karol@codete.com if you have any questions related to machine learning, especially in the security sector. All right. So the cases that I will discuss today are based also on some of my experience working with different companies, mostly in the DACH region, but not always. We also work with companies from the US, Israel, UK, and also a few countries in Asia. So based on my experience, I run my company for about 11 years now. I do research in the AI for about 15 years now. So I'm one of the person who can say I did machine learning before it was cool, like it is now. All right, so let me give you a short introduction to the topic of security, or maybe even to machine learning and the hype that is behind it. So you've probably heard about AI is the new electricity, or AI is the new UI, this kind of terms. Yes, well, now we have a hype. It's not the first one, not the first hype about AI. We had already a AI winter in the 80s, 90s. It was about methods that the governments and the researchers found out that actually the methods are not good enough at that time. And in 2006, it changed because Jeffrey Hinton with the team, they introduced the deep learning, and another hype approach actually started in 2006 or just after that. Now we are, let's say, in the top of the hype on machine learning. Everyone wants to do that. Even when I actually started my company, I tried to convince my potential customers to use some machine learning models, build some machine learning models, and they were against it. So it changed a lot, changed the mindset, especially during the COVID times. It changed as well because there was a huge drive on automation, and machine learning is part of it. But actually, what's behind the hype? 30% of the startups, AI startups, AI startups, they call themselves as AI startups. They don't really, in Europe, they don't really use AI. So 40%. That's really true. I mean, it depends obviously how we treat that. Because if you talk about linear regression, for example, that's not machine learning. Technically, it is a machine learning method, but it's known for many years and really isn't really so useful in many cases. And I wouldn't call a startup an AI startup just because there is a machine learning method used. There is more than that. It's about the whole transformation, the whole process. But why they startups call themselves AI startups? Well, if we don't know what is it about, it's about money. They will get from 50 up to 50% more funding from the ventures, from the private equities, ventures, venture capitals. Obviously, if we would get more money, we would also would like to say that we are an AI startup. That is not always good, because that's why also many startups, most of the startups that are not only startups but also in general AI projects based on Gartner research fail. So 85% is quite a huge number. One of it is because of the hype. The other one is because of some failures that are made during the development, during the process, and also some part of it is related to the security. So far, security was not really the biggest topic when we talk about machine learning models. It was like, oh, okay, that's not super important. We don't care about the security because this is just a model that we need to predict. But as we will see in a minute, there are some cases where actually the security was a major, say, factor, or the lack of the security was a major factor of the failures that I will show you. So again, machine learning is a buzzword like blockchain, like data science, like cloud computing. We had that before. Even some topics in machine learning, like chatbots, for example, were quite popular some time ago. Now it's not so popular anymore. So probably we will still have a few years where actually machine learning will be still a buzzword. It might change. Probably at some point we will get to AI winter again, but let's see. In my opinion, we will, the next stage, let's say, will be connected with the quantum computing and combining it with machine learning. But that's still not major enough. So we will need to wait at least a couple of years for that. So hype, that's a hype from 2019. I couldn't actually find a newest one from Gartner. And so you can see some of the topics. Some of the topics are more, let's say, more the hype. The other ones are more major, like speech recognition. Chatbots that here in 2019 was on top. Really now is actually somewhere here and down on the hype cycle chart. So it's changing. I mean, AI is not just, it's just one term. It actually consists of many smaller terms that you can see here. And security is now one of the topics that's popping, is going up. So failures. You can see here. Here is an example of you might heard about it in the past. I mean, a couple of years ago. It's not something brand new. When actually a Tesla car, autonomous one. I mean, when the driver wasn't really driving the car, was crashed against a truck. You can see here, because it was recognized as the background, right? So that's, I mean, background on the road, like heaven or something like that, clouds and so on. It was considered like that instead of a truck. So that's a mistake. Well, it might not be 100% connected with security because, well, it's more related to data. But I will show you why data is also important. Why is the security of the data so important? Oh, this is another one from 2016. It's about the Tide tweetbot. That's one of the last offensive tweet that I found. So you can imagine how are the other ones. Tide tweetbot is a tweetbot that was developed by Microsoft in 2016. As you can see here, here's the publishing date. So 5 years ago, it was a teenager. I mean, as a profile, as a bot, and because of let's say, I would call it a security issue because it was related to retraining and to feeding it with different kind of data. In this case, racist data. In 24 hours, this tweetbot became a racist, right? So Microsoft closed this project soon, just after they recognized it went in the wrong way. But well, they fixed that, but still, that's something that they just missed, how to secure not to be fed by this kind of data. There are many ways how to do that. I will not go into details. One of it is obviously is the checking the data. What is the intent of the data that is actually going into, and filtering it. Here another one, adding some stickers on different kind of signs. In this case, our stop sign might change also the recognition of, well, recognition of the sign is one thing. Second thing is misinterpreting the sign. Or here another example. This is a newer one from 2019, where actually Alexa was recommending the person, her, that the person that was listening to should suicide herself for the better good, for a greater good. That obviously not the right thing. This is not how it should work, and that's also an issue that can be connected to the data, but also to the security. Or IBM, well, I didn't find any specific picture of this algorithm because this was an algorithm model. They have built some time ago a model to recommend drug prescriptions for cancer patients. And obviously in the testing phase it went well, but then when they introduced it to a wider audience, this model was it recommended drugs in such a way that actually the patient passed away faster than without this kind of prescription. So they are also turned it off, and that's also a very serious issue. Or here, Google, again, in this case, racist one, not well done when it comes to the data overfit and well, in general, bad. Here, another case from Uber. This time hitting a bicycle, not recognizing it on the street. All right, but that's just a few examples. I just showed you just a few examples how it can be done in the wrong way. I mean, these are the most, let's say, one that actually you might heard about in the newspapers, on TV, and so on. But there are many of models that are attacked that you not heard about. That happened. I would like to go more into the details what kind of attacks we have, and next what kind of what's actually under the hood. So how the attacks works. So in general, the goal here, let's say we have three classes. So we have the green, yellow, and blue classes. Just to simplify that, the way how we want to, or the goal here is to make the algorithm or make the examples be again yellow or blue in this case, but be on a different way. So decrease the accuracy, right? Accuracy, but also data quality metrics in general. So that's the overall goal, to simplify that. And what kind of types we have? So we have white box, black box, when it comes to the way of the knowledge about the model. And we have also, when it comes to the label, the class, when we talk about prediction, if it's targeted, or untargeted. Targeted means, okay, we want to misclassify to a specific target. Untargeted, just misclassify. There are different kind of taxonomies. I will share with you also the slides after my presentation. So you will also find more description, because we just have 45 minutes, so you can read more papers here that I will show you in the sources here on the bottom of my presentation. So when it comes to taxonomies, there are different ones depending on the knowledge we have, depending on the algorithm, and so on. So there is no one algorithm or one way of attacking, or one, let's say, level of type of attacks, right? The other thing that is important when we talk about different kind of attacks is the environment. If we have an isolated environment, right, in this case, the input from the services, right, is isolated. So it means there is no user who has can affect this kind of a service, so that it's predictable or it's robust when it comes to the input we get to the neural network. In this case, obviously, I talk about neural networks, but in general, any kind of machine learning method can be attacked. So if we talk about SVM, if we talk about regressions, or any kind of, it can be attacked. There are plenty of papers, research papers showing how to attack a specific method, not just one. But I simplified that to our neural network. And obviously the output also to services without the input of our user that is outside from the environment. The opposite, obviously, is the non-isolated environment. We have the input from the user, so we get the input, return the output to the user. The other might be the same user, might be the other user, but in general, the user has an influence on the model. So that's a more dangerous, obviously, approach. But actually, most of our models that we want, especially if we go to production, are not isolated. What we can do, we can obviously filter the input from the user and try to at least make something in between non-isolated and isolated environments. But that's also a topic to the MLOps and deployments, serving the models. So white box attacks, it's well, it's clear that I mean the person who wants to attack this kind of model knows the architecture, knows the parameters, at least more or less knows the parameters, knows how it was trained. So with this kind of knowledge, we are better prepared to do such kind of attacks. So we know what's in it, so we can easy attack this kind of a network. The opposite is black box. We don't know exactly what's the network. So what we do, we try to base on the black box, try to send some input. I mean, give some input. Let's say images, right? If it's a computer vision model, and based on the output, try to make a substitute of a network that works similar, right? Train your own model, and in this case, you will be able to find out what's actually under the hood. What is the model that it works here? Even if it's a black box, you try to go make it for your own purposes, kind of a white box at the end. It will not be exactly the same. I mean, it's very rare that actually you can get the same one, but at least you can have a similar one. So targeted attack, everyone you see here on the top and the bottom, a car, right? So when we have on the top, we have a typical classification. So we see here on the car, so it's more than 90% sure that it's a car. When we talk about targeted attack, we want to attack in this way that there will be no car recognized here in this picture, but a button in this case, right? So we want to target that actually the model will recognize this kind of object as a button instead of a car, as you can see here, right? So the probability, I mean, the probability here is quite low for a car and it's high for a button, and some other values here for other classes. Untargeted attack. So we have at least two types. I mean, two most popular ones is the one who actually reduce the confidence, right? So again, we have the same car, the same classification on the top. On the bottom, we have the attack results. So as you can see here, the probability of the car prediction is much lower. It's about 30% only instead of 90. We increase the values for other labels. Still, it will be classified as a car probably, but the confidence in this case is reduced. And in some cases, it might be that the car confidence would be even lower than the other ones. And if it's so low for the other ones, that actually the other one is any kind of label is actually higher, like in this case. On the bottom, we have untargeted attack. But untargeted attack, that is actually focused on misclassification. So what it means, we don't care if we misclassify to a button or to a box. We just want to get a different prediction. so we try to reduce the confidence in a way that it will be just misclassified to anything else, like in this case. In this case, we have a box. All right, so what are the attack types? Some of these I already mentioned. So when it comes to number of adversarial attacks papers, just to go back to the research, it's increasing now because the topic is more and more popular. As you might have heard about the topic like MLOps, right? It's also become more popular because the way how we deal with the models, it's now more professionalizing, let's say. It's more professional in the way that in the past we did a microservice from that. It was done in many cases just not in an automated way. Now we have tools like Kubeflow, for example, to automate the whole process of getting the data, pre-processing it, preparing for training the model, deployment, serving, and so on and so on. So that's something that is more popular, and also because of that, the adversarial attacks, because we have more and more applications of machine learning, there is also there are also more papers and more research on that. So specific attacks, because I gave you before that I just gave you a taxonomy, more or less explained what type of attacks we have. But going specifically to your type of attacks, we have the poisoning attack. That's one. That's an image that I took from the paper that is here in the bottom, mentioned in the bottom. So what we want to do here is poison the data, right? Manipulating the data that is collected. In this case, we need to. I mean, not in always, but we can. We should have. Because as you can see, we have poisoning attack when we have access to training, or evasion attack if we do it on the testing level. So the goal here is to change the data in general that is used for training or testing. All right, and the classic Panda example, if you read an article or found any kind of paper on adversarial attacks, you might found this article about the pandas. Actually, panda, because there is only one panda here on the screen. I know you see two. But well, if I would ask you what's on the picture, on the two pictures, you would probably say on the left there's a panda, on the right there's a panda. But that's not true. I mean, for us humans, that's true. But for the neural networks, in this specific example, I mean, this article, it is recognized not as a panda, at least the one on the right. It's recognized as a gibbon. Gibbon is a type of a monkey. Why it is like that? Because there are some ways to add noise to the picture that is not recognized by humans, right? You can see we don't see any difference, right? That is recognized by the neural network. In this case, we can fool the neural network and make it make the prediction wrong. Here you have some other examples, a black box one. So here in this case, you can see the pictures here on the left and the right are a bit different, right? There is on the right there is a noise added, and you can see there's a viaduct or a bridge, right? That these are the classification, prediction results, and that's actually true, right? That's what we see also on the picture. But on the right here, just adding a bit of noise, you can see that it's not a viaduct, not a bridge, but it's a window or screen, right? And so on. So just adding noise is one of the ways how to fool the network. Another one, interesting one, is actually to add a sticker. That's a patch attack. I mean, it's called a patch attack. But what we do here, we add a sticker just next to the object we want to recognize. In this case, we have a banana, and on the top you see it's recognized as a banana with a very, very high confidence. But on the bottom, just adding the sticker, it's not a banana anymore. It is a toaster, right? And there are many examples of such stickers and ways of adding not just noise, because noise is, as you can see here, it's not really recognizable by humans. In this case, it is recognizable by humans, like the sticker. We see there is a sticker on, let's say, on kind of a wood surface. But still, we as a human, we just see a sticker, and we just when we focus on the banana. If I would ask you what's on this, what's on here on the picture, on the bottom one, you would probably say there was a banana and something. There was nothing really specific here on the sticker, right? So we'd rather answer there was a banana on the picture. Even more sophisticated attack is the one pixel attack. So there are 4 images here. I took this image from this article here. You can see a pixel that is, because it's very hard to show the pixel change. So it's marked with a red circle here. So there's a pixel change here. It's here, and it is, what is it here? It's here. Let's see. And just changing one pixel in the image change the classification results. So the prediction from cup to a zoo pole, from a teapot to a joystick, from a hamster to a nipple, and so on. So you can see that actually just changing one pixel. So it's easy to change one pixel. Obviously, you need to know what pixel you want to change to make the prediction totally different. But that's well, at the end, it's just a very simple operation that you need to do on the image to for the network. Oh, another one, something that I partially showed you before. So the stop sign, we have other signs that can be also affected with some stickers, some changes that make it unrecognizable by, for example, by the neural network. That's also called as a camouflage, right? So trying to hide, or hide is the best word here. Of the object that we see on the image. All right. There is another one, other patch that I would like to show you. You have 2 humans, 2 mans on the picture, and well, the neural network is here. In this case, it's about to recognize persons on the camera. The one on the left is recognized as a person. The one on the right is not recognized by a person. Obviously, by humans, we recognize 2 persons on this picture. But the one on the right has kind of a picture on it, right? Painting, let's say, on it. You can even, I guess, find still on Amazon T-shirts with this picture, not to be recognized by the neural network models, because in this case you see the person on the right is not recognized as a human being, just wearing this picture. So you can find the T-shirts and then try to fool the networks with this kind of a patch. And the same in real world, you can see here there was a washing machine or washer, just changing a bit the way how it is displayed. We can change to a save or a loudspeaker, for example. Okay, so what's under the hood? So how does it work? It's totally, the prediction is still different. So in general, what we want to achieve is the blue line here. So adding new features or actually extending the number of data, we want to get a classification error to this. When we talk about overfit, it's actually the red line here. So it's going down to some degree, and then it's actually going up. And actually, this applies to any kind of model. Obviously, adding more data doesn't always mean a better prediction. Adding more features doesn't mean better prediction as well. In many cases, it doesn't make much sense also to add more features. One of it is actually overfitting, and the other thing is that, well, it depends on the cases. If you have the number of features close to the number of objects you have, then obviously there is that's an issue. So the goal of many of the methods is to find, depending on the method, it's to find the minimum, that's the majority, or find the maximum, depending on the function we have. Obviously, the global minimum, right? So depending on the on the methods that you use to optimize the training. Like here, some of these are faster, some of the other ones are slower. Like here, you can see the SGT doesn't work so well, but ADAGRAD or other data is much faster. Just to mention 6 from these, but obviously we have plenty of different kind of methods here for the training, for optimization. So gradient descent is the most popular one. I mean, popular method to find the global minimum. The goal is here, if you have a loss function, to find the global minimum, and that's actually the point where actually our prediction is the best one. You get the best results, so the loss function is lower. The classification, the prediction error rate is lower too. And that's when we talk about the equation. That's how you draw it as an equation. But the goal of an attack is to not gradient descent, but actually try to make it as a gradient ascent. So it means not to find the minimum, but try to go away from the minimum. In many cases, there is no need to actually do the gradient ascent, because just not finding the right parameters make it in a way that actually we just hop over this minimum and just go in the wrong direction. And obviously this is just simplified, right? This is only 2 dimensions. In many cases, the dimensionality is higher. So as you can see here, the sign here, there is a -1. Here's a +1, so that's the way how we want to do when we want to process with the attack. So what's the overall way how the neural network, I mean some of the networks at least, work? So we have a back propagation, and we update the weights here. When we talk about an attack, we just freeze the way the process of actually updating the photo, the image, and try to find an image that actually will, in this case, will misclassify. So what are the defense methods? There are plenty of defense methods that we have. One of the methods is called fast gradient sign method. One thing that I should mention maybe before I go into the defense method. So there is no one perfect method. So it means there is no method that works always or can defend you totally against this kind of attacks. Knowing if the attacker knows the method that is used, I mean the defense method, in many cases the attacker can actually find a workaround, find a way how to fool even the defense method. So that's an issue, right? That's an issue because any kind of model we build can be affected. And can try to make it better, try to decrease number of attacks, but still we are affected. Fast gradient sign method is one of the methods to actually change a bit to work on the, as you see on the loss function here. That's one of the way how you can defend against the method, against the attacks. There are some other methods like Jacobian based science map and so on. I mean, if you go and find some research papers on the defense method, you will find plenty of such. One of the methods actually like here are about changing or actually carrying out the weights that we have, or the loss function. So going typically to the defense method, one of the most basic ones, let's say that it's not really mathematical designed, it's the due diligence meaning. So due diligence is more about it's a meaning that actually should be done before the project that you are about to build is started, right? So when we talk about, especially when we talk about the hype, there are just a few really cases where the machine learning can be used to really add value to your business. In this case, you can see it as the cases here in the middle, like with the orange one here. The due diligence meeting. I'm not now discussing the due diligence when it comes to the finance of a startup. More about the project and the AI useless or usefulness or application. There are many things that you can do with machine learning, with AI, right? And this is what will the AI expert tell you. Okay, that's doable, that's doable, that's not doable. And there are some also domain experts, like the medical field, finance field, and so on, that will tell you, oh, okay, that's something that will, this is our application, there's a case where actually we will get some benefit from, as a company. And just a few will really make sense. When we talk about the due diligence meeting, it consists of 5 questions. One of it is, it's divided into two parts. One of it is the technical part, where we have 3 questions. We ask ourselves, like, is it really doable? So is it really here in the blue circle? What kind of data really we need? Why is this question here? Is because many projects fail because of lack of data, or not good enough data, let's say. And there are plenty of such examples where actually the companies failed. Even I gave a training to a company in Germany about machine learning methods. And we obviously did a really nice training. Everyone had a knowledge about the model, the methods that can be used, and how to use them. But at the end, we find out that actually this is not the issue. The issue here was the data that wasn't really collected well, or lack of the data that can be used for machine learning. So that's very, very important to think about data. And some of the cases that I showed you before are also, the failures are also related to the data part. And obviously security here means also to keep an eye on the data, right? So what kind of data we have, is this data secure? Is it also normalized? Is it divided properly? In the meaning that we, let's say, just a typical example, if we talk about an illness like cancer, for example, on images, cancer in general is a quite rare illness. Not in general a cancer, but let's say a specific one. Let's say skin cancer. So if you take 1,000 pictures of moles, there will be, I don't know, 2, 3, 5 cancer cases. The rest will not be cancer. So it means you can get a model that will achieve 99% of accuracy, but will not find any cancer. So that's also very important. What kind of data you have? Who has access to the data, right? Who can actually change anything in the data, like poisoning, for example. The last question in the technical part is about do we have capacity? Can we deliver? Do we have people who already know this topic? Can we develop it? That's also a very important question, because now finding good data scientists in the market is quite it's not easy. And also the business section. Can we reduce the cost or increase the revenues? So from a business point of view, doesn't make any sense. Or can we launch a new product, right, or a new business service that might give us more money? All right. So more about the defense methods. Dropout. Just that's a method that is well known in neural networks. It's about regularizing some of the weights, some of the neurons, and that's also a good method to defense. Not the best one. We should use that just to defend against adversarial examples, but it's not enough in many cases. So weight decay, that's another one that we can use. It's connected somehow with the dropout, but doesn't need to be a dropout in general. It might be just changing the weights importance, let's say. And that's also not a bad method. Still not the best one, but this is something that you can use for defending against this kind of attacks. Another one is input transformation. So what I show you before, let's say with a tight beatboard, when we have a non-isolated environment, transforming the input, trying to change it, try to get features out of it. For example, when you talk about NLP, we can think about again about intention, right? For example, or the words that are used there. So we don't want to have words that might be racist, for example, right? Or offensive in general. So that's something we can exclude eventually if we get this kind of a data as input. We can, well, transform it, right, to less offensive, or just filter it totally, not to be used for the retraining. And that's an attack that, again, still can be, as the other ones that I mentioned before, can be you can find a workaround, but it's quite good to start from when it comes to the defense of our model. A very tricky one. I mean, tricky in the meaning that let's say, or maybe not tricky. Better word would be smart one, is to use the original data set and then retrain it using the adversarial attacks, adversarial examples from these attacks, just by changing the label, right? So train, let's say if we have a noise on the picture, and try to add these images with a noise to our training data set. All right. So that makes the model more robust. Feature denoising, that's another one. So we're adding one, let's say, kind of a layer in our network to denoise the features. That's another one. Denoising, like trying to delete this noise that we have on the picture. This might be also a quite good method for when you want to defend. So summary, have a due diligence before you start your project. Think about explainability and the environment that you run your machine learning models. If it's isolated, non-isolated, how you want to transfer the input, how you want to secure against user input that it will not affect. What about the retraining? Yeah, sure. If you don't have a retraining, it might be easier, but in many cases, the retraining is a must-have. And yeah, plan the data flow from the user, from the training. Think about the adversarial examples as ones that actually you should also use for the training to make your model even more robust. And that's all. I have still 2 minutes, so I think we can go to the Q&A. I hope you have a question. If you don't have now any questions, you can always find me on LinkedIn or during the conference on the chat.
Thanks, Karol, for all your insights. We do have a few questions. The first one is, from your point of view, which industry or area is mostly open for security flaws regarding machine learning?
Obviously, the one that actually work on sensitive data, like medical field, fintech, obviously, these are the two ones because they are regulated. So on one hand, they are regulated and they need to work on with explainable models. That's one thing. On the other hand, any kind of attack might affect it more, let's say, more than the other industries. I mean, in general, this kind of attacks can affect any kind of industry, but I think the two ones are the most critical ones.
Okay.
If we can prioritize.
And we have seen different attack modes today, and the question now is, what can do the audience about it? So how can we defend ourselves in the best way?
Well, we can use some of the defense methods that I just explained. This is one of the way. I mean, I just explained just a few, and obviously, if you go to find some research papers, you might find another ones. I think from the all that I showed you, the smartest one is actually to think about the attacks that you, I mean, let's say predict that you you can be sure that you will have some attacks. So instead of waiting for this kind of attacks, you can obviously use the dropouts and so on. But also what you can do, you can prepare this kind of a noisy data set, for example. So try to build a data set that is already that might be used for this kind of attack and try to make it robust. That's the let's say not simplest one, but the smartest one to be more robust. But again, there is no one magic defense method that will defend any kind of attack. So please keep that in mind that we still need to work. There's a continuous work.
As we are running out of time, one last question by Christoph he's asking, are there any commercial attack scenarios? So the first, it was more academic, but what about commercial attacks?
Well, the thing is that some attacks that happened wasn't really published, right? So the companies that are attacked, they are not likely to publish this kind of information, right? And yes, most of them are academic. Some of the attacks you found, I mean, you can think about academic, but it might also happen as a commercial one, right? All of that one that I showed you can be translated to commercial ones. Again, from the ones that I showed you, Thai for sure. Okay, Tesla and Uber, it wasn't really, I mean, it was more a mistake on the data, right? They didn't really secure it properly, but it wasn't really, I wouldn't consider this like a something that was done by purpose. Yes, they were. I can find you and send you some links after the presentation.
Yeah, and the last question is: are there any methods to detect whether a model was attacked or poisoned? So, are there any methods already out there?
If we can check if we were attacked, yes. I mean, not specifically methods. That's actually what you should do on the output of the data of the prediction, right? So what you need to do, you need to find anomalies, like kind of anomaly detection of the prediction that you get, and try to compare it to the previous predictions. Kind of a logging system that you can apply. And obviously, it depends on that. What is the output? If it's the image, and obviously there will need to be something done on the image. If it's an NLP, you can, for example, first of all, get the intent or find out if the answer from our model is positive or negative, right? How positive it is, how negative it is. So that's something that you can measure easily and find out if the output is really something something that you did. It's like, you know, when we talk about security and actually finding, it's when we talk about machine learning security and trying to find attacks that happen, it's similar to the typical attacks you do. What you do, you find a or you can even do a honeypot, like, you know, trying to build a model that is dedicated to be attacked and try to find, okay, who is attacking it, right? So by monitoring the flow here. So that's all about finding the logs and then trying to find anomalies in most cases. But there are, again, depends on the output. If it's a text, if it's an image or something else, you can do it in a different way.
So if you have any further questions to Karol, you see, have deep insights into that, please don't hesitate to ping him directly. Thanks for watching this session about machine learning security, and see you in the next session. Thank you, Karol.
Thank you very much.
Bye.
Bye-bye.